Hello, I'm Kaini. Here we have one equation which looks a bit strange. Sine z equal to 2. We know that it's a very simple question. We can just write z equal to sine inverse of 2, but here are getting a math error because sine is between 1 and -1. Therefore, there is no solution for this. Then why and how we want to solve it? The thing is that this is a complex number. Therefore, there is no real solution. There is no real solution. There is no solution. Therefore, in the complex plane, we can get the value for sine z equal to 2. There is a complex number solution. There is a complex number equation to solve. Okay, now let us try to use the complex number formulas to solve this. We know that e to power of I theta is equal to cos theta plus I sine theta. So e to power of negative I theta is equal to cos negative theta plus I sine negative theta. We know that cos is an even function, therefore this will be cos theta. And odd is an odd function, sorry, sine is an odd function, therefore this negative comes out. Therefore this is negative I sine theta. Now, if I subtract this from this, I'm going to get e to the power of I theta minus e to the power of negative I theta. Therefore, this cancels this. I'm going to get 2I sine theta. Okay. Now, just from here I can say sine theta is equal to e to the power of I theta minus e to the power of minus I theta divided by 2I. There is an identity. So here I can say sine z is equal to 2. That means this one is equal to 2 in terms of z. Therefore we can say that e to the power of iz minus e to the power of minus iz divided by 2I is equal to 2. Cross multiply here, you are going to get e to the power of iz minus e to the power of minus iz is equal to 4I. Now let e to the power of iz be equal to x. So you are getting x minus 1 over x is equal to 4I. Multiply by x, bring one side, you are getting x squared minus 4I x minus 1 equal to 0. Now you have a quadratic equation in the complex plane with the complex coefficient, so we can solve it. There is a quadratic equation. You can use any formula to solve. Therefore, x will be equal to 2I plus or minus the square root of minus 3. Therefore, this is actually 2 plus or minus the square root of 3 times I. Because this -1, the square root of -1 is I can factorize I. Therefore, this is the value of x. But I want value of z. Therefore, I can say e to the power of I theta is 2 plus or minus the square root of 3 times I. From here I can say, therefore, ln of this is equal to I theta. Therefore, I theta is equal to ln 2 plus or minus the square root of 3 times I. Okay. Ln of A times B will be ln A plus ln B. Therefore, I theta is equal to ln 2 plus or minus the square root of 3 plus ln I. This is a real number. You can find the log of this. There is no problem. This is ln of this. You can find. Ln is log in the base of the Neperian number e. Okay, whatever is, so this is easily can be calculated. What is ln of I? Now let's see I is what. I can write I is equal to cos pi over 2, which is 0, plus I sine pi over 2, which is 1. Therefore, this is I actually. But this is I can write e to power of I pi over 2. You can add 2 pi to any of this angle. Therefore, one of the solution is this. In general, you can write I is equal to e to power of I 2 pi k plus pi over 2. Okay, so now we want to find this ln of this. Therefore we are getting I theta is equal to ln 2 plus or minus square root of 3 plus ln of this, this comes down as a coefficient, therefore I times 2 pi k plus pi over 2 ln e. Ln e is 1, therefore this is the answer. Now if I divide throughout by I, I'm going to get theta equal to 1 over I ln 2 plus or minus square root of 3. This I get cancels, 2 pi k plus pi over 2. Usually we don't like this. You can write it multiplied by I here and here, therefore theta will be equal to minus I ln 2 plus or minus square root of 3 plus 2 pi k plus pi over 2. K can be any integer. You can see that the theta, oh sorry, hey, I made a mistake. What mistake I've done? Here is not theta, all this theta is actually z. Therefore this is z here, this is z here, this is z here, this is z here, therefore the value of z, therefore the value of z. We found the value of z, therefore you can see that the z, the value of z is a complex number. This is the real part of the complex number, this is the imaginary part of the complex number, therefore this is a complex number. If you want me to solve any question for you, put them in the comment section below, and I can go through that and then I will solve it for you and put it in our channel. Thank you for watching.